Welcome to my seminar on design of cold-formed steel exterior wall connections. I want to start by encouraging you to submit any questions that you may have as we go through this presentation. Feel free to include the slide number and I'll try to get up to all of your questions or comments during our three question and answer sessions. So let's get started. All right, so here's what we're going to talk about. We're going to talk about the code required loading and the building movements that exterior wall systems need to accommodate. We're going to talk about the typical wall framing configurations that you'll run into, the loading on those wall framing configurations and then thus on their connections, and then we will get into some heavy design on the connections themselves, both engineered connections and proprietary connections, so off-the-shelf connections. A little note about the terminology that I use. Cold form, I use it pretty synonymously with light gauge framing, so you hear me use both. And then gauge versus mills. I spend most of my time in the 18 gauge and thicker world, so it doesn't really matter to me, so I will use gauge much more often. But there is definitely a trend to be using more of the mills, because when you get down to 20 gauge material, there's actually 33 mil and 30 mil that's both considered 20 gauge, and then there's 20 gauge equivalent, which is even thinner. So, but I'm stuck in my old habits, so I will most likely use the gauge term. So let's jump right in. So for our code required loading, obviously we have our dead load, live load when applicable. This won't be very common in our situation here on exterior walls, but it does happen. We'll talk about wind load and we'll talk about seismic load. So for the first part, for dead load, it's pretty self-explanatory. It's the wall self-weight. So once built, the full weight of the wall itself. For a typical exterior wall, it can vary quite a bit. So for like a metal panel finish with one layer of drywall each side, you can easily be down at 10 pounds per square foot for your exterior wall weight, versus if you have a full 4-inch brick finish, you can easily be up to 50 pounds per square foot. So the loads that the exterior walls have to accommodate for dead load can be quite different. Building dead loads, so this would be the weight of, let's say, a floor slab, things that are going in here. In general, we design the exterior cold form steel walls to be non-load bearing, meaning that they aren't taking any of the load, the dead load from the building. However, if you were to put a wall between these two slabs here and not put a gap to allow this slab to move, then these wall studs would be subject to the building's dead load. Similarly, for live loads, again, if there's no gap or movement joint to accommodate allowing the building structure to move differently than the exterior walls, then the exterior wall would need to be designed for the tributary live load. Wind loads. So I'm going to talk about the 2021 IBC in this presentation. There are a couple places using the 2024 IBC, but it's not very common and definitely not here out in California where I am. So we're going to stick with the 2021 IBC and talk about the loads that are required in ASC 716. So for wind loading, we go to Chapter 30. We want to make sure that we're using components and cladding loads, that we're not using the main lateral force resisting system loads. For exterior walls, there are corner wind pressures and non-corner wind pressures. For heights, buildings that are less than 60 feet, the corner wind pressures can be a little bit higher, maybe up to 27%. When you get into taller buildings, your corner wind pressures can be significantly higher. So it's something that as engineers, we need to work with our client to, one, assess what the loads are, and then two, see if it warrants providing different framing and maybe connections at the corner zones. The loads do decrease with the increased tributary area. So if you have a longer spanning stud, there's an allowance in ASC 7 allows you to take the span times the span divided by 3. So your wall studs can technically be designed for a lesser wind load because it's a higher tributary area than possibly your connections can be designed to. So it's something to keep in mind as you're doing your design and how intricate you want to get into it.